So, let's wrap up our discussion about the banking system by reviewing the bank loan from the beginning, where X bought a house from S for $300,000 and took out a loan of $200K in the process. We assumed that the commercial bank in our example had neither deposits nor cash reserves yet. Nevertheless, it is regulated by the central bank and thus has to keep at least a 10% reserve of base money for all checking accounts. In our example, as a first step, X deposited his money with the bank and subsequently took out a loan of $200K. As I pointed out, the bank did not have the $200K it promised to X, but it gave him the loan anyway. And why shouldn't it? After all, it could actually make a loan of $900,000 and still be within the mandated reserve requirements. Now, X used a check to transfer his funds from his checking account to S, and in return, he got the deed to the house. So, after all transactions have taken place, X owns the house and has a debt of $200,000 to the bank. S has a checking account of $300,000 with the bank. The bank has $100,000 in cash and a loan worth $200,000 to X. At the same time, it has a liability of $300K to S, which makes for a reserve ratio of 33%. This lending process might look different than what the goldsmith did. After all, he never invented deposits for gold he did not have when extending a loan, but only lent out a fraction of the gold he actually had in his possession. But this observed difference is only a mirage. Upon closer inspection, one finds that both approaches to lending yield exactly the same outcome in the end. Anything that can be achieved with the first one can also be achieved with the second one, and vice versa. So they are actually equivalent. Let me demonstrate. If the commercial bank were to operate like a goldsmith, X would have to start out by paying S for the first third of the house. Now, S could take the money he received by selling the first part of his house and deposit it in the bank. Then, the bank could loan X $90,000. Its reserve ratio would drop to 10%, right at the legal limit. Now, X could use the $90K to buy another part of S's house. Again, S could put the cash in the bank. With the bank's reserve ratio climbing back to 53%, it has enough reserves to make another loan of $81,000 to X. X could again use the money to buy yet another part of the house, and S would yet again deposit the cash with the bank, increasing his checking account to a balance of $271,000. Finally, the bank has enough reserves to satisfy X's desire for another loan of $29K to pay the last part of the house. After S has taken his last payment to the bank, we have reached exactly the same picture as before. X has the house and the loan, S has a checking account for $300K, and the bank has $100K in cash and the loan to X. So, there is fundamentally no difference between both scenarios. One simply required a few additional transactions, but the actual outcome is identical in both cases. So why bother and go through the trouble at all? Finally, one last way to look at fractional reserve banking becomes apparent when looking at the last example. What did the commercial bank do? It took S's deposit, which is in essence a very short-term credit that is being renewed every day, and relent the money to X for a much longer term. But S is not aware of this duration mismatch and thinks he can really withdraw all the money he deposited at the bank at any time. As soon as the bank extends the credit of $90,000 to X, the assumption in S's head is no longer true. He could only withdraw the $10,000 the bank kept in reserves, and not $100,000 as he assumes. Then, as X pays S for the second time, using the money he received through his loan, S does not realize that he just re-received his own cash. Instead, he thinks it's new money, deposits it in the bank again, and now thinks he can claim even more cash from the bank than before. In our example, $190,000. $90,000 more dollars than there are actually in existence. S wouldn't have this wrong assumption if the bank actually told him that it lent his money to X for a certain amount of time, and that he could only withdraw it again once X has repaid his loan. So the final way to look at banking is that banks borrow short-term, lend long-term, and keep their depositors in the dark about it. We now have a basic understanding of the banking system as it exists today. Of course, there are still a lot of missing details, but we know enough to answer the first question from the beginning. Where does money come from? We now know that before we can answer this question, we should probably ask, what kind of money are you asking about? If it is simply paper currency, then the answer is, it is created by the central bank and spent into the economy by buying interest-bearing assets or through repurchase agreements. If one is asking about book money, then the answer is, commercial banks simply increase the balance in an account when extending a loan, and act as if they actually have the paper currency to back it. But since people are usually able to convert the number in their checking or savings account into paper currency, people understandably assume that commercial banks could do that for all of their deposits, and thus these account balances are being treated as money also. Perhaps a shorter, more general answer would be, nowadays, money is practically created solely out of debt. Debt that carries interest. This leads to a very crucial observation. Since money is lent into existence in exchange for a promise to repay more money later, the available amount of money is always smaller than the amount of outstanding debt. So, how can debt with the outstanding interest ever be repaid? A common thinking error is that due to this fact, it is simply impossible for all loans to be repaid, without anybody having to default or take on a new loan to pay the old one. But this is, at least in theory, not necessarily true. Let's first illustrate the example of an impossible loan and then see how the situation could be mended. Imagine a small economy of 3 people: a creditor, perhaps a banker, a debtor, perhaps an entrepreneur, and a consumer. In this system, we assume that in the beginning, the creditor has all the money, $2. The debtor has an idea for a business. He owns a garden with an apple tree that grows 1 apple per day, and he knows that the consumer would be willing to buy apples for $1 each. His only problem? He lacks the necessary tools to pick the apple. Luckily for him, the consumer sells a gardening device that allows him to cut the apple from the tree for $2. So, let's imagine in this first scenario that the debtor takes out a loan of $2 from the creditor and agrees to pay back $3 in 3 days' time. So he receives the $2 from the creditor and uses it to buy the gardening device from the consumer. He then starts working and uses his gardening device so that at the end of the first day he has successfully produced his first apple, which he then sells to the consumer for $1, just as predicted. The same thing is repeated on the second day. The apple tree grows a new apple, which is again harvested by the debtor and sold to the consumer for $1. On the third day, another apple is grown and harvested. But now, with the looming deadline for his loan, the entrepreneur faces a big problem. While the consumer would still gladly pay $1 for an apple, he has run out of dollars with which to pay. After all, only $2 entered circulation through the original loan. In fact, in this scenario, the entrepreneur has no chance to avoid default because he has agreed to repay $3, even if there are only $2 in existence. An impossibility. I think it is important to stress that the entrepreneur did not do anything wrong per se, except perhaps agreeing to the unsatisfiable loan contract. But as soon as he had agreed to it, his fate was sealed. Even if he had been able to invent cold fusion or some other miraculous product or service, short of counterfeiting the missing dollar, he would have been unable to repay. But there is actually a way to repay a loan of $2 and the additional dollar of interest if there are only $2 in existence. All that is needed is a slight change in the loan contract. So let's look at the second scenario. Again, we have the same creditor, debtor, and consumer, but this time the terms of the loan are a repayment of $1 every day for 3 days for an initial loan of $2. So, similar to the first time around, the creditor lends a debtor or entrepreneur $2, so he can in turn buy the gardening device from the consumer. He then proceeds to cut the apple from the tree and sells the apple for $1 to the consumer. Now, it is the end of the first day, so he gives $1 back to the creditor. On the second day, the same transactions take place. He sells his apple to the consumer and receives the $1, which he in turn hands over to the creditor. Now, the fateful third day arrives, but this time the situation is different. Last time around he already possessed all the money in the system, so there was no one left to sell his apple to. But this time, his creditor actually has the money to buy an apple from him. If he does, then the entrepreneur is able to pay back the last dollar at the end of the day, without having to default on his promise. But notice the two critical prerequisites it took for the loan to be repayable. The creditor had to spend at least the interest, in the previous case $1, back into the economy. If he hadn't, the debtor couldn't have earned the interest, simply because it was not in the system. Also, the consumer was not allowed to hoard any money, but had to spend it again after he got hold of it. It would have still worked if he had only spent $1 on an apple and kept the other dollar to himself. But then the creditor would have to buy 2 apples and would have ended up with only $1 after all transactions had taken place. So, we find that for loans to be truly repayable, that is, without having to take out additional bigger loans or defaults, money has to keep circulating and creditors have to consume at least their earned interest. If even a single participant does not play by those rules, but keeps accumulating money, eventually all funds will flow to him, leaving the debtors unable to repay their debts because he has sucked all the money out of the system. We don't even have to look at complex institutions, like commercial or central banks, to realize that these prerequisites are obviously not fulfilled in reality, because there are normal private individuals who manage to accumulate enough money to easily cover their living expenses with only a fraction of the interest they receive, thus accumulating more and more money over time. It therefore follows that the only way to deal with loans, other than defaulting, is to take out new and bigger loans. This generates a cycle that feeds on itself. Since the interest paid on a loan is a percentage of the principal, the size of new loans has to grow exponentially. If you're not familiar with exponential growth and its ramifications, there are several great videos on this topic on YouTube, such as the ones I put up here, and I urge you to watch them to get a real grasp of what exponential growth really means and entails. I will only present the topic briefly and highlight a few important facts. Let's begin with the definition. Something, like a population, an amount of money, or an economy, is growing exponentially if it grows perpetually by some percentage of its current size whenever a fixed span of time passes. For example, loans with compounding interest grow exponentially. But another equivalent definition of exponential growth that is much easier to grasp is that something grows exponentially whenever it doubles in a fixed span of time. There is a simple formula that is pretty accurate to get to the doubling time from the typical percentages of growth per unit of time. It goes as follows. If something grows by X% per unit of time, then it takes about 70 divided by X units of time for the entity in question to double in size. For example, if you have a savings account that pays 1% of interest a year, it will take about 70 years for your savings to double. If it pays 2%, it only takes 35 years. If it pays 10%, it only takes 7 years to double your money. Another useful rule of thumb is that when something has doubled its original size 10 times, it is approximately 1,000 times its original size. Accordingly, if it has doubled its size 20 times, it is approximately 1,000,000 times its original size. If you draw a graph of the amount of the quantity in question over time, if it grows exponentially, you will get a hockey stick chart. That is, a chart that looks pretty flat in the beginning and seems to accelerate greatly towards the end. This is one of the main problems with exponential growth. If you have a fixed supply of something and your consumption grows exponentially, practically until the very end, it looks as if you still have a lot of reserves left, until they are gone practically in the blink of an eye. But enough with the theory for now. Based on the analysis of money creation and the mechanics of loan repayment, I made some very bold claims, saying that in our current system, debt grows exponentially, and that because of fractional reserve lending, there are actually more forms of money than just the paper in our wallets. So, let me show you that the data actually supports these hypotheses, and that I haven't just made all of that up.